let's jump right into this explainer because we are dropping straight into a massive supply chain arms race. And it's one that's about to collide head-on with a monumental regulatory deadline. We're talking about the global textile industry, an absolute juggernaut. And right now, there's a battle raging at the microscopic level. It's a war over cellulose fibers, the regenerated wood pulp that makes up a huge chunk of the clothes we wear, the sheets we sleep on, and the technical textiles we use literally every single day. Seriously, next time you check the tag on your favorite shirt, you're probably going to see one of the three major players we're breaking down today: Viscose, Modal, or Lyocell. But hey, this isn't just a chemistry lesson. This is a high-stakes corporate survival story, because looming right on the horizon is the 2026 EU Digital Product Passport. And this piece of legislation is going to force a level of radical transparency this industry has literally never seen before. To really wrap our heads around the scale of this battle, we've got to start at the bottom line: $2.30. At just $2.30 a kilo, traditional viscose absolutely dominates the global market. I mean, it is the undisputed volume leader. Why? Well, because it's incredibly cheap to produce, and it delivers that beautiful, soft drape that consumers love. And let's be honest, that fast fashion brands rely on to keep their margins nice and wide. From a pure cost to aesthetic ratio, traditional viscose has basically been the engine of global apparel for decades. It is everywhere. But the hidden costs are, quite frankly, catastrophic. We're looking at a manufacturing process that's riddled with toxic chemical hazards, not to mention a fiber that literally degrades the second it hits water. For years, the industry has kind of just looked the other way, right? Accepting these massive environmental and structural flaws as simply the cost of doing business at scale. But let me tell you, the era of looking the other way is rapidly coming to an end. So here's the crucial question. With the impending 2026 EU Digital Product Passport totally prying open these global supply chains, which of these cellulose fibers is actually built for the future? When regulators step in and demand to see every single chemical used, every drop of water consumed, and every mechanical test passed, that cheap veil of traditional viscose is going to be ripped right off. We're about to find out which supply chains are built on rock-solid engineering and which ones are about to turn into massive compliance liabilities. Section 1. The fatal flaws of viscose. Okay, to understand why the industry is low-key panicking right now, we first have to deconstruct this legacy tech. Traditional viscose relies really heavily on caustic soda and carbon disulfide, or CS2. Now, CS2 is a highly toxic chemical used to break down the wood pulp, and it creates an absolute nightmare for both worker safety and environmental compliance. When untreated, the emissions in the wastewater from this chemical-heavy process are just incredibly harmful. Brands sourcing cheap viscose are already facing intense scrutiny from NGOs. And under the new regulations, this chemical footprint is going to have to be publicly declared. It's basically a toxic trail that leads right back to the brand. And that brings us to the structural failure of the fiber itself. Viscose has a low degree of polymerization. In plain English, the molecular chains holding the fiber together are weak. Sure, when viscose is dry, it has moderate strength and that gorgeous silky drape. But the exact moment it gets wet, like say in your washing machine, it swells, it distorts, and it loses up to 60% of its strength. It literally tears itself apart over time. This total lack of dimensional stability means a super short product lifespan, which completely contradicts the new circular economy mandates rolling out of Europe. Section 2. The modal upgrade. You see, the industry knew viscose was fundamentally flawed when wet, so they engineered a patch, a way to fix those structural failures without losing that soft, luxurious feel. Enter Modal. When we contrast these two fibers, it is super clear how Modal changes the game entirely. By utilizing controlled chemical processing and really high drawing during the spinning phase, Modal achieves a wet modulus that is 2 to 3 times higher than viscose. I mean, just look at that wet strength retention, jumping from a dismal 50% all the way up to an impressive 90%. And by shifting from just generic wood pulp to specifically refined beechwood pulp, the resulting fiber actually resists water penetration and stops that disastrous wet swelling dead in its tracks. So Modal isn't just a slight improvement, it's a complete structural overhaul. It features enhanced polymerization that actually stops the rapid degradation of the cellulose chain. Because those molecular bonds are stronger, you get finer, much more uniform filaments. It can withstand over 10,000 Martindale abrasion cycles, which is just a fancy way of saying it resists pilling brilliantly. Plus, its hydrophilic properties mean it absorbs 50% more moisture than cotton. That makes it an absolute powerhouse for activewear and intimates. The exact stuff you're probably wearing right now. It is a massive step up from traditional viscose in both performance and durability. Section 3. The 2026 Open Loop. But as impressive as the Modal upgrade is, the entire industry is about to hit a massive regulatory brick wall. It's no longer just about making a stronger fiber, it's about proving exactly how that fiber was made, start to finish. Let's trace this timeline, because this isn't some distant abstract future. Starting in July 2026, the EU's central DPP registry goes live, accompanied by a hard ban on the destruction of unsold goods for large enterprises. Then just 2 months later, in September 2026, the EU completely bans unsubstantiated green claims, meaning if a brand says something is eco-friendly, they have to provide verified, certified proof. This kicks off an open loop of mandatory supply chain data that is going to expose legacy greenwashing forever. If your fiber relies on toxic processes, the data will show it and the regulators will definitely see it. So, to survive this new open loop of regulatory data, the ultimate answer is Lyocell's closed-loop manufacturing. This is a totally different paradigm. Instead of toxic carbon disulfide, Lyocell uses an organic, non-toxic solvent called NMMO. And here is the truly incredible part. This process perfectly recovers and reuses 99.5% of that solvent. It's almost a perfect closed loop, which drastically reduces chemical hazards, water usage, and toxic discharge. By nearly eliminating those chemical hazards and wastewater contamination, advanced lyocell fibers, like Lenzing's Tencel, for example, effortlessly meet the EU Ecolabel and ZDHC, or Zero Discharge of Hazardous Chemicals standards. When these 2026 regulations actually go into effect, brands using this closed-loop lyocell won't have to scramble to hide their chemical footprints. They'll be able to proudly display them. This represents the absolute gold standard for impending compliance. It's a beautifully engineered fiber that is as strong environmentally as it is physically. Section 4. The DPP Data Matrix. So, how exactly will these fibers stack up when the regulators actually come knocking? Let's take all this engineering and environmental data and run it through the actual requirements of the incoming EU legislation. The DPP isn't just a tag or a static PDF. It is a dynamic, bidirectional data system built on 4 incredibly strict pillars. First, precise garment classification. Second, tracing every single operator in the supply chain using a global location number. Third, and honestly, this is the killer for cheap textiles, detailed technical specs. That means mechanical robustness and a full, transparent inventory of substances of concern. Finally, Pillar 4 requires third-party verified compliance documentation, literally tracking a garment from its raw material extraction down to its specific chemical footprint, right to its end-of-life recyclability. When you matrix these 3 fibers against the impending 2026 regulations, it is an absolute blowout. Just look at this landscape. Traditional viscose is a massive compliance liability. We're talking high risk for toxic emissions, massive water usage, and incredibly low mechanical durability. Modal, it's a highly viable upgrade for sure, offering way better durability and a much cleaner footprint. But Lyocell is the indisputable benchmark for the future of technical textiles. With its closed-loop chemical management, low water usage, and premium tenacity, Lyocell is pre-engineered to absolutely ace the digital product passport requirements. As we wrap up this explainer, I want to leave you with this thought. The textile industry is standing right on the edge of a massive paradigm shift. The days of opaque, toxic supply chains hiding behind shiny marketing campaigns, they're officially numbered. When the 2026 DPP mandate strips away all that marketing and the hard data is laid bare for regulators, recyclers, and consumers to see, will your fiber choices hold up under the microscope, or is your entire supply chain going to break down? It's time to choose your materials wisely. Thanks for joining me on this deep dive, and keep learning.